Hello, and welcome to the Computing Conversations column. This column is from the October 2015 issue of IEEE Computer and is titled Anant Agarwal, Inside edX. There is supporting video material for this column that you can find in the IEEE Computer Society YouTube channel or in the IEEE Digital Library. I'm the editor of the column, and I'm Charles Severance from the University of Michigan. Massive Open Online Courses, also known as MOOCs, in which enterprising professors teach free courses online at scale, burst onto the scene in early 2012 with the emergence of providers such as Coursera, Udacity, and edX. I spoke with Anant Agarwal, the CEO of edX, which was created by MIT and Harvard University and hosts university-level courses in numerous disciplines to students around the world. Agarwal taught the first edX course on circuits and electronics from MIT, which drew 155,000 students from 162 countries. In its third year, edX has enrolled more than 5 million students from all over the world and offers more than 500 free courses from the world's best universities, colleges, and institutions. The courses cover a wide range of topics, from architecture to social science. Not surprisingly, computer science courses are in high demand.
There are just a large number of jobs out there which are unfilled. And the degrees that people get, they don't quite match up to the skill levels required by the job. So there's a real skills gap. And so we feel that a lot of the computer science courses can help bridge that skills gap.
In addition to classes that provide critical skills to students already engaged in their careers, edX can also improve the pipeline of incoming computer science students. These courses can get students started and be useful throughout their education.
We have computer science courses that start at the early, it could even be taken by kindergartners. There's a programming in Scratch course, which is a great course for an early introduction into programming for a kindergartner, or for that matter, for the parent of a kindergartner. All the way up to very advanced courses. So for example, we have a course on cloud computing from the IEEE. There are courses on software as a service from Berkeley.
With such a broad offering, students can forge a non-traditional path to learning technical skills.
A lot of the students that are taking some of the computer science courses are not computer science majors. So for example, one of our learners sent us a letter saying that she was an English major. And she was never quite sure did she want to go into technology or into the humanities and liberal arts. She ended up doing English. But late in her college career, she decided, hey, let me try a computer science course. So she took Introduction to Computer Science from Harvard at edX, and she really liked it. And she says, hey, maybe I'm going to top off my liberal arts education with some computer science courses, and that will help me get jobs in fields where there are jobs asking.
An important part of self-directed study, which is integral to edX courses, is the student's ability to take time to understand difficult topics on their own schedules.
I think pressure and stress is part of the culture at some of the top universities, and students thrive in it. That said, we have a large number of self-paced courses where the students can dive in and learn at their own pace. And if they pass the course, they get a verified certificate, which they can post on their LinkedIn profiles, on their Facebook profiles, and so on. And when students take these courses in a self-paced manner, they can certainly afford to be a lot more creative and explore a lot more and take a lot more time than a fixed regimen course.
Constructing their own curriculum and setting their own pace allows students to follow more creative interests.
There's also a lot of design aspects to computer science. You just have to take the Scratch programming course from Harvey Mudd to realize how much fun kids can have with programming. Programming is not just about writing code and looking at ones and zeros, but in the Scratch programming course, for example, kids can do animations and a lot of fun stuff involving video and audio, and it's just a fantastic introduction to computer science and programming.
Teaching edX courses also benefits computer science faculty.
So computer science faculty certainly are very excited about offering online courses. And they're taking the same online courses that they create on edX for the world for free offering as a MOOC, and also bringing it back to campus in a blended model. I'll give you a couple of quick examples. One is T.C. Pong, who's a professor of computer science at Hong Kong University of Science and Technology. He teaches a great Introduction to Java course on edX. It actually turns out that Java is the single highest searched term on our website. And so he offers a Java course on edX, and he also used the same course on campus to involve campus students.
The experience gained building large-scale open enrollment courses for edX has led to changes in on-campus offerings as well.
But students like MOOC courses to be relatively short, so they can plan their time much more effectively around it. So MIT took their 4-month Intro to Computer Science and Python course and broke it up into 2 parts, Part 1 and Part 2, each running about 6 to 8 weeks. When campus students noticed that, they said, hey, that's a really good idea. I want to take the second part of the course, or just the first part, not both parts. And so, believe it or not, they also split up the campus course into 2 parts to reflect the online course. And so you can see that experimenting online, people have the freedom to experiment online. And then following that experimentation, they can apply what works in campus courses as well.
Even with the success of edX, there's much more to do.
We have just a very simple vision. We would like to educate 1 billion people over the next 10 years. And we're trying to head in that direction. And that involves creating lots of great courses, improving the engagement and assessments of the courses. We've got some extremely rich assessments in computer science and for the humanities and peer grading and AI assessment and so on. So we're not only teaching computer science, but we're also using the latest in computer science and machine learning and cloud computing and big data to improve what we're offering on the platform as well. So I hope that within a few years, we will be able to offer just absolutely spectacular courses in virtually every topic known to mankind, getting up to maybe 10,000 courses in 3 to 5 years.
Technology has been used to enhance teaching since the mid-1990s. Nearly every campus has some form of a learning management system. Historically, computer science faculty members tend to avoid the campus-wide LMS, preferring to build their own software so they can tinker with their environments as technology evolves. The edX platform emerged from this tinkering and has become a mainstream product. As the platform continues to grow, and as these types of courses begin to change the requirements for online education, the MOOC platform software might ultimately reshape the entire marketplace for software that supports teaching and learning. This column is from the October 2015 issue of IEEE Computer and is titled Anant Agarwal, Inside edX. There is supporting video material for this column that you can find in the IEEE Computer Society YouTube channel or in the IEEE Digital Library. I'm the editor of the column, and I'm Charles Severance from the University of Michigan.